Imagine a world without zero. You can't. Try counting without zero. Impossible. Zero, as absent as it may seem, is fundamental to our universe. We use it every day, yet its existence is paradoxical. It represents nothingness, yet it holds immense power. Zero is not just a number, it's a concept, a revolution in thought. Before zero, mathematicians struggled to express emptiness. They had symbols for 1, 10, 100, but nothing for nothing at all. How could they quantify the absence of something? This seemingly simple question puzzled civilizations for centuries. The story of zero is a journey of human ingenuity, a testament to our ability to conceptualize the abstract. It's a story that traverses continents and cultures, ultimately shaping the world we know today. The earliest hints of zero emerged from the cradle of civilization. The ancient Babylonians, renowned for their astronomical observations and sophisticated mathematics, developed a placeholder symbol around 300 BC. Across the world, the Mayans, independent of Babylonian influence, incorporated zero into their calendar system. They used a shell symbol to represent zero, signifying completed cycles and the beginning of new ones. These early civilizations recognized the need for a symbol to represent nothingness, albeit in a limited way. However, it was in ancient India that zero truly blossomed. Indian mathematicians, around the 5th century AD, developed a comprehensive understanding of zero as a number and not just a placeholder. The great mathematician Brahmagupta defined zero's properties, outlining its role in arithmetic operations. This marked a paradigm shift, propelling mathematics into new dimensions. With Brahmagupta's groundbreaking work, zero finally found its rightful place in the world of mathematics. The concept traveled westward, carried by Arab scholars who recognized its immense value. It reached Europe during the Middle Ages, initially facing resistance from traditionalists. However, the elegance and efficiency of the decimal system, powered by zero, eventually prevailed. Zero simplified calculations, paving the way for advancements in algebra, calculus, and other complex mathematical disciplines. The once resisted concept became an indispensable tool, revolutionizing scientific thought and laying the foundation for modern mathematics. Section 4. Zero's Triumph, the Cornerstone of Physics. Zero's influence transcended the realm of mathematics, profoundly impacting the physical sciences. It became a cornerstone of physics, playing a pivotal role in our understanding of the universe. Isaac Newton, the father of classical mechanics, incorporated zero as the starting point for measuring motion and forces. His laws of motion, describing the relationship between an object's motion and the forces acting upon it, rely heavily on the concept of zero velocity and zero acceleration. Centuries later, Albert Einstein, in his theory of special relativity, used zero as the constant speed of light, a fundamental principle governing the nature of space and time. Zero, once again, proved essential in unraveling the mysteries of the cosmos. Section 5. Zero's Paradox, Nothingness or Everythingness. Despite its ubiquity, zero remains an enigma, a paradox that continues to intrigue philosophers and scientists alike. Is zero truly nothing, or does it represent something profound? In mathematics, zero often acts as a neutral entity, neither positive nor negative. Yet, it possesses unique properties. Adding zero to any number leaves it unchanged, highlighting its neutral nature. Multiplying by zero, however, collapses everything to itself, showcasing its power to annihilate. In physics, the vacuum of space, often considered the epitome of nothingness, is teeming with quantum fluctuations, particles popping in and out of existence. This suggests that even in the absence of matter and energy, there is still something, a fundamental ground state, perhaps represented by zero. Section 6. The Reign of Zero, From Computers to Cosmos. Zero's significance extends far beyond theoretical realms, shaping our technological landscape and influencing various fields of study. In computer science, zero, represented as a binary digit, bit, forms the backbone of digital information. The binary system, consisting solely of zeros and ones, underpins the functioning of computers, smartphones, and the entire digital world. In cosmology, the study of the universe's origin, structure, and evolution, zero plays a critical role in understanding the Big Bang theory. The universe, according to this theory, originated from a state of zero volume and infinite density, a singularity where the laws of physics break down. Section 7. Zero's Uncharted Territory, the Future of Nothingness. As we delve deeper into the quantum realm and explore the vast expanse of the cosmos, zero's significance continues to grow. In quantum computing, which harnesses the bizarre properties of quantum mechanics to perform complex calculations, zero plays a pivotal role in qubit states, the quantum equivalent of bits. The quest to unify quantum mechanics and general relativity, the two pillars of modern physics, may also hinge on a deeper understanding of zero. Some theoretical frameworks, like string theory, propose the existence of extraspatial dimensions curled up at incredibly small scales. These extra dimensions, potentially existing in a state of zero size, could hold the key to unlocking the universe's deepest secrets. Zero, the concept that once baffled ancient civilizations, has become an indispensable tool for unraveling the universe's mysteries. Its journey from a placeholder to a fundamental concept is a testament to human ingenuity and our relentless pursuit of knowledge. As we continue to explore the cosmos and delve into the quantum realm, zero will undoubtedly continue to guide us, reminding us that sometimes nothingness holds the key to everything.